Assalamualaikum warahmatullahi wabarakatuh and good day. In this video, I'm going to explain to you the properties of the root locus and how to solve the problem using MATLAB. If you haven't seen my previous video on the properties of the root locus, please click on the suggested link above. Let's say we have the transfer function, the closed loop transfer function equals to kgs over 1 plus kgh. And from this, we can get the characteristic equation, which equals to 1 plus kgh equals to 0. And we have kgh equals to negative 1 plus j0 in Cartesian form. And in polar form, we have magnitude and angle theta. And we can say that a value of s is a closed loop pole if the magnitude, which equals to kgh, absolute value of kgh equals to 1, as well as the angle of theta of kgh equals to 2k plus 1 multiplied by 180 degree. Okay, let's say we have this problem here. We have this diagram, a plant with a unity feedback system, and we have k s plus 3, s plus 4 over s plus 1, s plus 2. So let's say let's say we have this example here. Let's say we have s at negative 2 plus j3. So how do we know that the s is on the root locus? So we can do manual calculation, as I have explained in the previous video, or we can use MATLAB to solve this problem. So we have, for this, we have s equals to negative 2 plus 3j. And we can just make this transfer function here, s plus 3, s plus 4, over s plus 1 multiplied by s plus 2. So when we run this line, what we get is the resultant transfer function g equals to 0.4 minus 1.13i, or j. And we can find the theta from this complex number using angle. We want to find the theta, which is the angle. We can use a function angle, which will give you the angle in radian. That is why when we want to find the theta in angle and degree, we must multiply by 180 and divide by pi. So what we get in this example here, we have our theta is negative 70.56. So it is not a multiplication of 180 degrees. So we can say that this example here is not on the root locus. This example here is not on the root locus because the summation of angles here is negative 70.55 degree or 56 degree, which not equals to multiplication of 180 degree. And then we have another example here. We have our s now is negative 2 plus j square root 2 over 2. So is this s on the root locus? So we can use MATLAB to solve for this problem. We have our s now is let me clear first, and we have our s now is at negative 2 plus 0.7i, and then we can find the resultant transfer function g, which equals to negative 3, a real value, and then we can find the theta, which in this case is negative 180 degree, so it's actually 180 degree. So what we can do is we can find the magnitude of GH. In this case, we find this, and we can find the value of k. In this case, is 0.3. So we can say that this point of s here at negative 2 plus square root 2 over 2 is on the root locus because the value of angle, the resultant of angle, summation of angles, poles and zeros is equals to 180 degree. And the point where the S located is with gain 0.3. right? So you can say this result is the same as calculation using manual calculation. And so we can say that two properties that is important for us to know if the S position is not or is on the root locus is by taking the angle here, which equals to 2k plus 1 multiplied by 100 degree, and also the kgh, which the magnitude of kgh equals to 1. Alright, so I hope you understand how to use MATLAB to solve for these problems. Alright, thank you for your attention. See you in the next video.